Hi everyone, so there are three types of plate boundaries that we're going to review today. So it's divergent, convergent, and transform, and we're going to define which each one of those mean and what they make and what they mean for our plates moving. So our first one is going to be the divergent plate boundary. This occurs when two plates are moving away from each other. So if I had to draw that, I would probably draw it with two arrows pointing directly away from each other. What is usually made here are some sort of rift valley or new sea floor. So this is where we're going to see mostly what we talked about with our hypothermal vents. They're going to be created by this divergent boundary, creating new sea floor here. And a great example of this in our oceans is our mid-Atlantic ridge. It runs right down, as you can see in this diagram right here, all the way down from the North Pole to the South Pole. So that's that really, really large divergent boundary, which is creating new sea floor. And what that means for our continents on the land is that new sea floor is being created. So our continents are going to be pushed further away on either side, because that's how that plate is going to be moving. So again, if we see here, as our plates are moving apart, we can see this rift valley start to come to be. And with that, we can see that the entire continent here is going to be sinking. And soon after, it's going to fill with water, and we'll see more and more water between these two land masses as that rift valley continues and as we see our plates keep moving apart in different directions here. Our next boundary is called a convergent boundary, and this occurs when two plates are colliding together. So a way I would diagram that is pointing arrows directly towards each other. So when this happens, we actually can see three different things happening with this. So let's go over each one. The first one is two oceanic plates colliding. So remember, oceanic plates is going to be where we see both oceanic crusts coming together here. And it's usually going to form some chain of volcanoes. So if we take a look here, we can see one oceanic crust is colliding into the next, and one is sinking underneath. As that one is sinking underneath, we can see these little volcanoes being created here. And a great example of that is Japan and the Aleutian Islands here. So as our crust is moving down underneath, we can see this mantle is creating some pressure and making these little islands within the sea, which is going to cause those little volcanic islands here. So that's when two oceanic plates collide. We're going to see one sliding below the other, and we're going to see a chain of volcanoes forming here. Our next one is when one oceanic plate and one continental plate collides. So since that oceanic plate is more dense, it is going to go underneath our continental plate. And again, it's going to form a range of volcanic mountains at the edge of the continental plate. So we're going to see a lot of molten rock here. An example of this is the Ring of Fire, Andes Mountains, and the Cascade Mountains. So let's see what that looks like. So as this oceanic crust is being pushed under, remember it is more dense, we're going to see this nice line of mountains right on the edge here being created. And some of those mountains are going to have the potential to become volcanic, just like our oceanic convergence here. So these have some potential here, and our Ring of Fire is actually something that's very common and very well heard of here. So what we can see is all of this is going to outline actually a plate here, and since it's an oceanic crust relationship, we're going to see that these mountains are going to be created. So we can see some mountains up here in Oregon and Washington. We see some mountains on the edge of Mexico. In Chile, that's our Andes Mountains. We'll see some volcanic islands over here as well. And all around this circle, because that's where the plate is moving. So again, we can see our Andes Mountains all the way down the edge of South America. We can also see a lot of mountains from Alaska into Canada down into Washington just a little bit. Oops. And then our last type of convergent boundary is going to be a continental-continental plate colliding. And again, we're going to see one continental crust moving underneath the next, and it's going to form a mountain range. So a great example is our Himalaya mountains. So these keep getting taller and taller because these plates are going to keep colliding and pushing the other plate up against it, as we see here. So again, we can see this is where our plate boundary is, and that's where our Himalaya mountains are going to be located. Our last type of plate boundary here is going to be our transform boundary, and a lot of times these are also called fault lines. So this occurs when two plates slide past each other. So how I would diagram that is drawing, that's a bad arrow, is drawing an arrow going in this direction and an arrow going in this direction. So when those plates slide past each other, we're going to see that one plate moves more north and one plate moves more south. And a great example of this is our San Andreas Fault in California. And this plate is really going to cause either vicious earthquakes or it can cause mild earthquakes. It depends on how much the movement happens at that fault line. So that's really dependent on how much we're going to see that pressure building up in our transform boundaries. But again, important things to remember here is that they're sliding past each other, moving either more north or more south here. So if we take a look here, we can see that before, these ridges over here were lined up, but since those plates were moving in an opposite direction, sliding past each other, we've seen a really big movement between those two, and that's what we would call a fault line here. So our San Andreas Fault pretty much runs almost the entire length of California. And that's why we see and hear of a lot of different earthquakes that happen within California. Though we have not had a really drastic earthquake in a really long time, there's potential for that to occur, and it's pretty much impossible to detect these earthquakes before they come, which is why they can be so dangerous. Though all those minor earthquakes, again, is that plate boundary moving within its fault. Okay, so that's where we're going to end today. If you have any questions, please feel free to reach out.